Hello. Today what we will do is learn to identify the slope of a line simply from its equation, not by looking at the graph of it, but by looking at its equation. And what that will require is some previous knowledge of equations and how they work, as well as fractions. So the previous knowledge that I'll walk through is understanding solving literal equations for a specific variable. For example, if you had the equation, 4x minus 3y equals 12, and we solve that equation for y, meaning get the y by itself, get this y by itself, undo everything around it. So currently what's happening to it, it's multiplying by a negative 3, knowing that this sign belongs to this 3. So the y is currently multiplying negative 3, then there's the 4x that's there with it. So it's adding a positive 4x. So we have to undo everything in the backwards order. When you see solve, we're thinking undo. So we undo 4x from both sides of the equation by subtracting it. And so we will have negative 3y, again, that sign belongs to the 3, negative 3y, and then we have to think about 12 minus 4x, which is 12 minus 4x. You can't subtract these two numbers because this has the x. This does not, there are not like terms. So you end up with 12 minus 4x. Finally, we divide both sides by negative 3. So when we get y by itself, we have y equals 12 minus 4x. All of that divided by negative 3. So we have to remember that piece of prior knowledge. We also need to remember about the commutative property of addition, which says that you can add things in any two orders, or in any order. So if we had a term that looked like 12 minus 4x, if we had that, we can rearrange it using the commutative property. So we can rearrange that expression by moving the 12 and the negative 4x. Remember, this sign belongs to the 4, okay? So it's a minus 4x. So we have, when we rearrange it, negative 4x plus 12. That's the commutative property. We also need, in our prior knowledge, to remember about fraction properties. So what are the properties of fractions that are important for this? When we have this giant fraction expression, a big old fraction expression, what we can do is split it up using that same denominator. The denominator is negative 3, so we can split up the numerator using that denominator. What do I mean by that? I mean that we can rewrite it so it looks like negative 4x over negative 3 plus 12 over negative 3. So we can split up this fraction expression into 2 using the same denominator. The other piece of fractions we need to remember is simplifying. Okay, so we have to remember that negative 4 over negative 3 is the same thing as positive 4 over 3. And we have to remember that plus 12 divided by negative 3, 12 divided by negative 3 is negative 4. Plus negative is just the same thing as negative. So we have to remember that part of fraction properties as well. The other piece of prior knowledge we need to recall are the x and y intercepts of a graph, remembering that the x-intercept is where the y is 0, and the y-intercept is where the x is 0. So we can remember that as well. And then lastly, we need to remember about equivalent fractions. So for example, if we had the integer negative 3, it can be expressed as a fraction as negative 3 over 1. It can also be expressed as 3 over negative 1. So these are all the pieces of prior knowledge we should have when we're talking about identifying slope simply from an equation. Requires all of that. So let's get into some new material. So what we can do to find the slope from an equation is using the X and Y intercept that we learned in the previous lesson. So if you recall, the X-intercept is where the line crosses the X-axis, and there is a point. Remember, it was a point. The Y-intercept is where the line crosses the Y-axis, and remember, that's a point. So we can find the slope using that, identifying the rise over the run of those 2 points. Okay, so remember, they had 2 ordered pairs. The X-intercept is an ordered pair, the Y-intercept is an ordered pair. We can count rise over run, or we can use the slope formula. So that's a way we can find slope from an equation. I'm not going to do any examples with that because we're going to do something a little bit easier. Because we've done these in previous lessons, you can go back to those lessons and learn how can I use those lessons to find slope. So what we can learn to use is something called the slope-intercept form of an equation. The slope-intercept form of an equation. An equation is in slope-intercept form when y is by itself, when the equation is solved for y. We have the equation solved for y, it is in slope-intercept form. And the reason why we call it slope-intercept form is that when the equation is solved for y, we can easily identify the slope and the y-intercept. So we can easily identify the slope and the y-intercept. That is the beauty of slope-intercept form. It makes everything super simple about identifying slope. So slope is the coefficient of x. The y-intercept is the other number hanging out there. And if it's y solved in slope-intercept form, super easy to identify that. So let's do a quick practice round. Take this equation, for example. Y is solved for, it is by itself. So it's easy using this equation to identify the slope and the y-intercept, although today we're focused on slope. The slope is the coefficient of x, okay, the number in front of the x. In this case, the number in front of the x is 1/2. So the slope is 1/2. What about that +4 hanging out there? That +4 is the y-intercept, which you may have picked up on that shortcut from the previous lesson on intercepts. So the 4 is the y-intercept, but the question of slope is 1/2. So you can identify a lot of things about this line just by looking at the equation. Slope is 1/2, y-intercept is at 0,4. Here's another example. So if we have another equation, y equals -3x minus 4, if I wanted you to identify the slope, you could, because y is by itself. This equation is solved for y, and we have it in slope-intercept form. Y equals mx plus b. Plus b. That says minus. It just means that the y-intercept is at -4, but again, we're focused on slope. So it's y equals mx plus b. The slope is the coefficient of x, the number in front of the x. When y is by itself, is the slope. So in this case, the slope is -3. The y-intercept happens to be, once again, 0, -4. So if an equation is solved for y, it is super easy to identify the slope just by looking at the equation. Here's another example. The equation is solved for y. It is super easy to identify the slope. Y equals mx plus b. I know you're asking, but there is no plus b. Yes, there is. You just don't see it. Plus 0. So y equals mx plus b. The m is the slope. The b is the y-intercept. And I know you're looking, well, there is no b. So the y-intercept must be 0. The y-intercept does exist. It is 0. The slope, the coefficient of x, is +2. So we have slope of 2, y-intercept at 0. Again, the y-intercept does exist. It is at 0. So what we can do is use slope-intercept form to help us with identifying the slope from many different equations. So we can write equations into slope-intercept form so we can learn about their slope and we can learn about their y-intercept. So we can use this information to help us out to find slope. So sometimes solving a linear equation for y, that's the easiest way to find out the slope. So here is an example. If we had the linear equation 3x plus 2y equals negative 6. If we had the linear equation 3x plus 2y equals negative 6, and I wanted to find the slope, I could solve for y. Make this equation look like y equals mx plus b. So we have to undo everything surrounding the y. So this is just like the example we covered in prior knowledge, so I can move quickly. What's happening to the y? It's multiplying by a positive 2 and then adding to it a positive 3x. So we have to undo 3x first. So we undo 3x from both sides. We will be left with a positive 2y equals, and then what is negative 6 minus 3x? Negative 6 minus 3x, we can't do anything about that. But remember, the goal is to make it look like y equals mx plus b. So we have to put that term with the x in front. Here's where we use the commutative property. We can rearrange these two terms using the commutative property, just like in previous knowledge. So we have 2y equals negative 3x minus 6, using the commutative property. Y is not yet by itself, so now we can divide both sides by y. And so we've divided both sides by y. Now what we can do is use the other piece of prior knowledge about properties of fractions. We can separate this giant messy fraction into two separate fractions with a denominator of 2. This piece over 2, this piece over 2. So we are remembering our properties of fractions. This piece over 2, there's the minus sign, this piece over 2. Finally, we can use the other properties of fractions to simplify our fractions. We would end up with y equals negative 3 over 2x. 6 divided by 2 is 3. So we have negative 3 over 2x minus 3. And what does this look like? This looks like slope-intercept form. Y equals mx plus b. So the slope is negative 3 over 2. The y-intercept is at negative 3. So the slope is negative 3 over 2. The y-intercept is at negative 3. And we can analyze the equation in that way. So let's do a couple more examples, and then we'll get into some trickier aspects of this. The next example we can work with, and I'll move a little bit faster. If we have the equation 4x minus 5y equals 15, how can we identify the slope? So we can solve this equation for y. And when we solve the equation for y, we need to identify what's happening to it, being multiplied by negative 5, and then there's adding that positive 4x. So we can undo 4x from both sides. Now watch these shortcuts. I'm going to take a couple of shortcuts. I'm left with negative 5y equals negative 4x plus 15. It's plus 15 because it's positive 15, and I've already used the commutative property in my head. Now I'm going to divide both sides by negative 5, and here is the second shortcut. I went ahead and used the property of fractions to split the division into two fractions. Okay, so I went ahead and used that property of fractions to split the giant fraction into two separate fractions with the same denominator. And now I can simplify. A negative over a negative is positive, and 15 divided by negative 5 is negative 3. And I'm already in slope-intercept form. So my slope for the second equation, 4 over 5. My y-intercept in this equation, 0, negative 3. So I can use my ability to solve literal equations to identify slope from a line. Now let's take some super shortcuts that you can only get by watching this video. I don't have it in my notes. Recall that the first equation looked like this. We had the x term, the y term, then the equal sign. The x term, the y term, then the equal sign. That's called standard form, but there's a shortcut to find slope from standard form. The shortcut is this. The coefficient of x over the coefficient of y, change the sign. Coefficient of x is 3, coefficient of y is 2, so we would say 3 over 2, but then change the sign. Positive 3 over 2, change the sign, is negative 3 over 2. Let's check our work. What would be the slope if we did it the long way? Negative 3 over 2. So if you can identify standard form, you can use that shortcut. Does it work all the time? Well, let's see this second example. I have the x term first, then the y term, then the equal sign. I can put the coefficient of x over the coefficient of y and change the sign. 4 over negative 5, which is negative 4 over 5. Change the sign. You will get positive 4 over 5. Let's see if that worked out. It sure did. Positive 4 over 5. So you can quickly identify the slope from standard form only if you watch the video and learn that shortcut. So now let's get into a couple of tricks before we wrap up here. What about vertical lines and horizontal lines? What about equations that are missing a variable? So here's an example. What if we had the equation y equals negative 6? There is no x term. So there is no x term, no x term. What does that mean? That means you're actually looking at y equals 0x minus 6. And when you compare that to slope-intercept form, the slope is 0. So, when we have no x, the slope is 0. When we have no x, the slope is 0. And what does a line with the slope of 0 look like? A horizontal line. So we have to be aware of this tricky case. This is a horizontal line. And recall from the last lesson what the y-intercept would be, remembering that there is no x-intercept for a horizontal line. So no x, the slope is 0, horizontal line. Here's another example. What if we had x equals 4? What would be the slope of this line? So you look at the equation and you realize immediately there's no y. if there's no y, there is no rise. That means, or there is no run, excuse me, there is no run. So the line doesn't shift anyway. There's no y. So what that means, since it doesn't make any sense, this is a vertical line. That means every single ordered pair on that line has an x-coordinate of 4, which means it's a vertical line. So what would be the slope of a vertical line? Undefined. Remember, vertical lines have undefined slope. The slope doesn't exist. So in the case of a horizontal line, the slope exists. It's 0. In the case of a vertical line, the slope doesn't even exist. It's just not there. There is no way to quantify it. Another way to check this is when you have y equals 6, what this means is that every ordered pair has the y-coordinate of -6. Every ordered pair has a y-coordinate of -6. So you can fill in the blanks, graph it, you will end up graphing a horizontal line. For the equation x equals 4, that means every ordered pair has an x-coordinate of 4. You can fill in the blanks with any numbers you can come up with, graph them, you will find a vertical line. And that is how we can use slope to find, we can use equations to find the slope of any line. In the next lesson, we'll get into graphing.